this problem, we will consider conservation of linear momentum in 2 dimensions. A car with mass 2,000 kilograms moving south is hit by another car with mass 2,500 kilograms moving east. After they collide, the two-car collision moves southeast at an angle of 30 degrees from south at 5 meters per second. What was the initial speed of the two cars? So let's start by drawing a picture of the situation. You have a car 1 and a car 2. Well, this is car 1, this is car 2. The car 1 is moving south, and 1 is 2,000 kilograms south, and car 2 is moving east. This is 2,500 kilograms. This is M2 equals that, and they collide, smash, and this final car moves together with a mass of M1 plus M2, alright, at an angle of 30 degrees from south, alright? So moving southeast. Okay, so we need to figure out basically the initial speeds of these two cars. So let's begin. Let's begin by writing down the equation for conservation of linear momentum in 2 dimensions. So M1 V1 initial vector plus M2 V2 initial vector is equal to M1 V1 final vector plus M2 V2 final vector. Alright, we do know, however, that these cars basically stick together and basically end up as a single unit moving to the southeast. So let's call this velocity VF for the two of them, and we know that V1 is equal to V2F, which is equal to VF, right? Because they stick together. Alright, so applying this, we have then M1 plus M2, VF vector is equal to that. Alright, so let's draw it in, let's write it down by component. So in the x direction, let's basically draw, this is my x direction, this is my y direction, okay? The x component of this vector equation is going to be M1 V1 initial, well, Vx1 initial, no vector there, plus M2 Vx2 initial is equal to M1 plus M2 Vx final. Alright? And we do know that Vx final, well, that's just going to be Vf times the sine of 30 degrees, right? And similarly, if you want to draw this right here, Vy final is equal to Vf, right, times the cosine of 30 degrees. And we know what Vf is. Vf is given right here, 5 meters per second. All right. So this is going to be equal to m1 plus m2 plus m2, all right, times basically Vf sine of 30. Okay, so let's just plug everything in. There's no x, there's no vector there. So m1 in this case is going to be this one, that's 2,000 kilograms, 2,000. Vx initial, this m1 is initially moving purely south. So in fact, this is actually 0 plus m2 is 2,500. Vx2 is what we're trying to find. Vx2 initial is equal to m1 plus m2 is 2,000 plus 2,500 is 4,500. Vf is 5 meters per second, given by this. And then sine of 30 is 0.5. Okay, so we can now break out our trusty calculator and go and get it. Okay, so let's get this thing taken care of. So this is 2,000, so it's going to be 0 plus 25 4,500 Vx2I is equal to 4,500 times 5 times 0.5. Let's plug that in into our trusty calculator to see if we can see it. So it's going to be 4,500 times 5 times 0.5. And that's equal to 11,250. 11250. Alright, so now this is pretty easy to solve. We have V2x1 is equal to, if you plug everything in, 4.5 meters per second. Alright, and so we know that this one is traveling initially at v of equal to 4.5 meters per second. Alright, now let's do the other one, right? The car that's moving south. For that, we need to consider the y component of this. So move this shift over just a little bit. The y component of this equation is just going to be m1 vy 1I plus m2 vy 2I is equal to m1 plus m2 vyf. Right, and we know what vyf is going to be already. It's going to be basically m1 plus m2 of vf cosine of 30. Now this is in the minus y direction, so there should be a negative sign here. And so this overall thing should be a negative sign as well. Right. So let's just plug this thing in here. Okay. So what we have is going to have 2,000 for m1 times vy1I, which we'll try and find, plus 2,500 for m2 times now vy2I. Well, this m2 is moving in the easterly direction, no southern component, so that's actually 0. Right, is equal to minus 4,500 times vf cosine 30, which is going to be 5 times 0.866. Alright, so let's plug this numbers in as well. So let's clear this thing out. So it's going to be 2,000 vy1I is equal to 4,500 times 5 times 0.866. And that is minus 19,485. Divide by this by 2,000, and we have our final answer. Vy1I is equal to minus 9.7 meters per second. Alright, that's a little higher than I hoped, but I think that's right. Let me just check this one more time. 4,500 times 5 times 0.866. That's correct. Alright, so this is correct. Okay, and so therefore we have our final answer. These two are correct. So the initial speed of this one is v1 is equal to minus 9.7 meters per second. Alright, and there we go. We're done.